The Earth is warming. At this point, very few people, even in the depths of the internet, deny this fact. But what I still hear over and over is, how do we know it's us? How do we know this is not just a natural cycle? I get it. After all, at one point Manhattan was under a mile of ice. Climate change has happened before. But scientists have been sure since about the 1960s that this change in the climate is being caused by humans. So how do we know? Let's start with the most obvious possible driver for a warming Earth, the sun. There are a few reasons we know the sun is not responsible for our recent warming. First, the measure of incoming sun energy to the Earth, called solar irradiance, has remained flat or actually decreased as our temperatures, in the red line here, have actually rapidly increased. This is especially evident since the 1970s. In addition, the air higher up in the atmosphere, known as the stratosphere, has been cooling, downward trend, since the late 1970s. That stratospheric cooling has been taking place while the troposphere, where we live and our weather occurs, has been warming rapidly, strong upward trend. Think about it. If it was the sun, how could the layer closer to the sun cool while the layer beneath it warmed rapidly? The answer is, it's not possible. That's how we've eliminated not only the sun, but any external influences. Now, carbon dioxide is a greenhouse gas. We've known that since the 1850s. And since then, we've known that greenhouse gases trap warmth in the lower part of the atmosphere. Generally, this is a net positive effect for life on Earth, as it keeps the planet warm enough and inhabitable. But too much of a good thing can have a negative impact. Using ice cores, which contain trapped air bubbles from hundreds of thousands of years ago, scientists have recreated the history of carbon dioxide in our atmosphere, and the graph is striking. So, while we've certainly seen natural variations in carbon dioxide in the past, nothing approaches the scale and speed of our recent run-up to over 400 parts per million. Okay, but maybe the extra carbon dioxide is from natural sources like plants and the ocean. What if I told you we caught fossil fuels red-handed with a fingerprint? There are 3 naturally occurring carbon isotopes on Earth, C12, C13, and C14, the last of which decays to nitrogen with a half-life of about 6,000 years. Why does this matter? Well, the carbon from fossil fuels has been in the ground for so long that the C14 isotope is almost entirely gone. So, by measuring the ratio of C14 in the atmosphere over time and watching it rapidly diminish, scientists can easily conclude that not only is CO2 increasing, but that CO2 is coming from the burning of fossil fuels. This phenomenon is called the Seuss effect. And since CO2 is a greenhouse gases warm our atmosphere, and fossil fuels have added CO2 to the atmosphere at an unprecedented rate, it's pretty much a 1 + 1 + 1 = 3 equation. And last but not least, the speed of warming. Although the climate has changed in the past, it has never warmed or cooled at this speed. Now you might say, how do we know what the temperature was so long ago, before thermometers? Well, scientists use a complex process of temperature proxies, including something we see a lot here in Maine, snow. There are measurable chemical differences in snow formed at different temperatures. Therefore, ice cores can be used to provide a record of temperature going back around 250,000 years. In addition, yearly banding is found in fossilized corals and lake sediment. Each band has a chemistry that reflects specific temperatures. Tree rings are also used as they get wider or thinner based on temperature. So scientists can say with a relatively high degree of confidence, the Earth has never warmed this quickly before. Put this all together and there's only one scientific conclusion to come to. Human activity is responsible for the vast majority of warming that has occurred on this planet since the 1880s.